right, so what we're going to do first, couple days of school is just go over some like basic review stuff. We're not even going to get into like heavy algebra yet. I think it helps to review a little bit rather than just jumping right in, because if you don't review and you jump right in and you're confused, then it just gets kind of frustrating really quick. So we'll just start with some basic review. So on your paper, just make sure you put your name on it. And you don't have to write down the entire question, okay? If you think it might help you, you could write it, but don't feel that you have to write down the whole thing. Okay? What I want you guys to really write down is the answers that we're going to figure out as a group. All right, so in algebra, a lot of times we use letters, okay, for things. Does anybody know in algebra when we have a letter that represents something we don't know, what we call it? Yeah, Aiden.
Variable.
Yeah, that's a variable. Okay, so what's in red, that's going to be the answer to one of your homework problems tonight. Okay, so in algebra, a letter that represents something that we don't know, that's called a variable. And we can use any letter we want. Okay, a lot of times you might see what letter in algebra? X seems to come up a lot, but you could use anything. Some letters we might not use, like the letter O. Why might that be a little confusing if we use the letter O? Yeah, Shannon?
You might get it mixed up with 0.
Yeah, it might be hard to distinguish it from a 0. And there's other letters, maybe like a lowercase l, could look like a 1, things like that. All right, but that's what we call something that we don't know, that's represented by a letter, is a variable. All right, let's take a look at the next one. Okay, this one's a little tricky. Okay, B. It says 3x plus 2 is an example of and. Now, and was a hint because if you put the word and, the next thing begins with a vowel. Kind of already showed, but if you're not sure, think about what class you're in, and that's kind of the first word here. Yeah? Close. It's a good guess. To have an equation, we got to have that in somewhere. Okay, so if I put like equals 4 on it, then it would be an equation. So this is almost like one side of an equation. Yeah, how about Vanessa? Yep, it's an expression, and specifically because it has a letter in it, we call it an algebraic expression. Okay, if you had something like this, that's not algebraic because there's no letters in it. This is just called numeric. That's a numeric expression. Okay, once we throw a letter in there, then it becomes algebra. Algebraic expression. Okay, any questions on that one? All right, so some of the things I asked you, it's not going to be all vocabulary today. We're going to go through like a couple where we have to solve something or simplify something. So we'll actually do some arithmetic out. All right, the next one. It says the process of replacing a variable or variables, if there's more than one, with a number. Does anybody know what you call that? Like if I said to you to take the number, I don't know, 5 and plug it in for x. Doing that has a name. And it's 3 words. Anybody remind me, what is 3x plus 2 an example of again? What is that? Yeah?
Algebraic expression.
That's an algebraic expression. And we're looking for a word that means when you plug something in and calculate a number. Anybody know it begins with an E? And it would be doing like something like that. Take 2, plug it in for x. Anybody know the word I'm thinking of? Begins with an E and then a V. Evaluate, yeah. So anytime they ask you to take a number and plug it in for a letter, okay, that's called evaluating an expression. Most of the time, you would see this as a direction. Okay, on the test, it may say evaluate the following expression. And what that means is they'll give you a number, and they want you to plug it in for the letter. And then once you do that, you can use your calculator, or you just do it in your head, and simplify and actually get that answer. All right, let's take a look. Take a look at this one. All right, so this one's not asking for a vocabulary word, okay, or a phrase. This one is looking for an expression, okay? I'm looking for an algebraic expression to represent that sentence. Hey, when you guys look at that sentence, does anybody see something important? Okay, there's some words in that sentence are more important than others. Yeah? Yes, that's definitely a very important word. It tells you what you're doing. Okay, you're decreasing, so we'll have to see what that means in a second. Anything else there that's important? It's probably going to appear in our answer somewhere. Yeah, how about Bailey?
N.
Yep, N is definitely going to appear in our answer. And one more thing that's important. Yeah. All right, so number of is there, but it's not something that's super important. What else do you think is important?
31.
31, yeah, I like that. 31. So 31 decreased by n. What does decreased mean? Yeah, it means subtract. Okay, so I'm going to put that in. And this says 31 decreased by n. Anybody tell me how I would write that? I want to take 31 and decrease it by n. Yeah.
31 minus 10.
That's it. That's what they're looking for right there. Actually, I think I already had it written. Okay, it's kind of like if I said, how would you write 10 decreased by 2? Well, that's just another way of saying 10 minus 2. Now, can I simplify that? 31 minus n? Is there anything I can do? What do you think? If it was something like 10 minus 2, could I simplify that? Yeah. That I can simplify because it's a number and a number. Is this a number and a number? No, it's a number with a letter. You can't simplify that. Okay, so there's nothing we can do. That's the final answer. That's it. Any questions on that one? Did you have a question, Josh? No? All right. All right, another one kind of like D. Okay, E, they're looking for an expression again. And it says the cost in dollars of one bracelet if n bracelets cost $6. You know what? I'm even going to simplify that a little bit. Let's just say, you know what? I'm going to change it because I think that's going to be a little tricky the way that's worded. I'm going to say the cost in dollars. I'm going to put the cost in dollars if each bracelet costs $6. Okay, I didn't change it a lot, but I just changed it a little. The cost in dollars if each bracelet costs $6. And you're going to buy n bracelets. Okay, so the cost in dollars if each bracelet costs $6. You're going to buy n bracelets. Right, so if you just bought one bracelet, how much would you spend? Just $6. What about if you bought two bracelets? Yeah, you have to take 6 and double it times 2. What if you bought 3 bracelets? 18. It would be 6 times 3. What if you bought n bracelets? What would the cost be there? Yeah, it would be 6n. Okay, whenever you're buying multiple of the same item and they cost the same amount, you multiply. You know, like if a gallon of gas is, I don't know, $2.10. If you want 13 gallons of gas, you got to take $2.10 times 13, however many gallons you buy. Okay, that one's a little tricky. Okay, but any questions on that one? It's a little bit tricky. All right, so this one is evaluate. What do you think the first thing you have to do to evaluate is? They gave me an expression, and then they said A equals 11, B equals 7. What do you think I'm going to do with the 11 and the 7? Yep, Vanessa? I'm sorry, Kaylee? Sorry. Yeah, what are you going to replace the A with? Yeah, you're going to take and plug in 11 for A. And what about B? What am I going to plug in for that? Yeah. Yeah, we're going to take and plug in 7. Okay, so that's our first step. Okay, we got 11, take away 7. Now, is that something I could simplify? Yeah, just take a second on your own and see if you can simplify it. On tests, you'll be able to use a calculator if you need to. Okay, so Liam, if we do 11 minus 7, what does that give me? Careful, if you did 10 minus 7, that would give you 3. 4. Yeah, 11 minus 7 gives me 4. And that's what they're looking for. Okay, so anytime you see the word evaluate, what that means to do is get a number for the answer. You're going to plug something in and then get a number. All right, same directions as F. Why don't you guys take a second and try that one on your own? Okay, just as a hint, what's in G that you didn't have to do in F? Nope, you're not going to have to cross multiply, but that's a good guess. Yeah, we are going to have to do that sometimes. Yeah? Yes, you have exponents and something else here. Yeah? You're going to have division as well. Okay, so take a second and see if you can evaluate G on your own. Okay, and I'll walk around and I'll help you guys out. Okay, so if you're stuck on G, H would give you a hint at the order you do things in. Okay? Does anybody remember there's a word that tells you the order to do arithmetic in?
Yeah, so H says, what is the acronym we use to solve when simplifying? Does everybody know what an acronym is? You know what that means? Like letters that stand for something, like NBA, National Basketball Association. Go ahead. What's your name again? I'm sorry.
Shannon.
What is it?
Shannon.
Shannon. Okay, all right, go ahead, Shannon. What do you got?
PEMDAS.
PEMDAS. Nico.
Can you tell me what's PEMDAS? What is that?
Parentheses.
So we got parentheses. Yep. What about what's the E?
Exponents.
Exponents?
Multiplication.
Multiply, yep.
Division.
Division,
Adding and subtracting.
add, and subtract.
It's like a rainbow or something.
Yeah, so we got parentheses, exponents, multiplication, division, addition, and subtraction. So it tells you the order to do things in. First two are pretty straightforward, parentheses and exponents. When you have multiplication and division, does anybody know what order you go in when you see it?
As you're looking at the problem.
Like a direction you move in? Yeah?
You go left, right?
Yeah, you always go left, right.
So those two guys, in addition and subtraction, they kind of hold equal weight. So the one that shows up first, going left to right, once you do your parentheses and your exponents, so when you get that multiply division spot, whatever one shows up first, going left to right, you do that one first. And again, a lot of this stuff's review for you guys, right? You've seen PEMDAS before, I hope everybody kinda, yes?
How about addition and subtraction? What order do you do that in? Yeah, you also have to go left to
Yeah.
right. So what that means is you might do subtraction before addition. It depends on the problem. If you had 2 minus 8 plus 3, the first thing you are going to do there is subtraction. You do 2 minus 8 first, and then add 3 at the end. Okay?
Mr. Hager, but if you were to do, say if you did the 8 plus 3 first, that's the negative 8 plus 3, would that still be okay?
You can go out of order of PEMDAS sometimes and get the same answer, but we'll probably stick with that. But yes, there are different ways to do the calculation, and sometimes you still get the same answer. But if you stick with this order, you'll never go wrong. All right, so how about, let's just go like that.
Guys, did anybody solve that one? G? What'd you get, like? How, that 4? Anybody else get anything? 4? Anybody else? Anybody else get anything different than 4? Anybody else? Anyone brave enough to say they got something different than 4?
I got 2.
Huh? Let's take, let's check it. Let's see hopefully I did it right. Check my answer.
Can somebody tell me how do I do it? Oh, you want to see the answer first and then we'll check it? See, 4?
Well, I could have done it wrong though. I asked Mr. Hager, that happens sometimes.
Okay, what's the first thing I do here? If I want to figure this out, Ashley? Yeah, so what are you going to fill in for x? Yeah, it tells me to fill in 2 for x. And I'm going to fill it in again right here. And somebody tell me what's going to go on the bottom. What minus what? Yeah, how about Nierka?
2 minus 1.
2 minus 1. How many people had at least that to start? Okay, let's check it out. Good. So now we've plugged everything in. Do I have any parentheses in that problem? Nope. Do I have exponents? Yes. So exponents is the next thing I do. How about Marissa? What's 2 to the 3rd power?
8.
Yeah, 2 to the 3rd means 2 times 2 times 2. Okay, how about Emily, what's 2 to the 2nd power?
2 to the 2nd power? 4.
4? Okay, so I've done my exponents. If I want, I could have done this in my head right now, 2 minus 1. If it's confusing to do multiple steps, just don't do multiple steps. Just do it out one step at a time. All right, where are we? Okay, I've done my exponents. Any multiplication here? Nope. Now, what about this fraction bar? That really fits in here somewhere. Does anybody know where that fits in? It's a little tricky. Yeah?
Division?
Okay, so we are going to do some division, but anytime you see a fraction bar, you always want to do what's in the top first and then do what's in the bottom. Okay, you don't want to divide 8 by 2 or anything like that. All right, so you want to think of this as a fraction bar, splitting that problem into 2. Okay, do the top first, then do the bottom. Okay, so what do you get when you do what's in the top? Yeah, go ahead, Kyle.
4.
Good, 8 minus 4. How about when we do what's in the bottom? Yep.
1.
You get 2 minus 1 is 1. Now, that's fine. You can leave a fraction as 4 over 1. And in fact, a lot of times when we need to make a number a fraction, that's how we do it. We put it over 1. But if you take 4 and divide by 1, what does that really simplify to? Perfect. Mr. Roy gets an A.
Not making mistakes.
Okay, I know I kind of did H while you guys were doing G, but did everybody have a chance to copy down the word PEMDAS for H?
Hey guys, if you know what that, I'm sure most of you guys, if not all of you guys, probably know what that means. And again, if you guys are writing everything down right now, even the examples, that's great, but you don't have to. All right, we're gonna give you a worksheet tonight that kind of recaps this whole thing. It's gonna have some notes on there for you guys to fill in. Because again, Mr. Hager and I thought rather than having you guys sit here, listen to us talk the whole time, have us write down every example on a note sheet, we'll give you guys that for homework. And we'll break it up a little bit.
Yeah, and if you are worried, again, this will be online, so you can always just check it if you need to find something. All right, why don't you guys try I and J, okay, on your own.
Guys, how many people, be honest, before you do when you do a math problem, you just go right to it? You just start working on it. How many people? Be honest. Be honest. How many people you sit down and you just start on a problem? Don't pay attention to anything else. Yeah, me too. All right? Why is that bad?
You missed steps.
You miss steps. What else? Any other idea? What's your name?
Emily,
Emily, what do you think?
can you mess up the problem?
Mess up the
The
problem.
answer?
I'm thinking, hey buddy.
I can't see the.
Oh, I'm sorry, Bob, I'm in your way.
No, I think.
Oh, yeah, you move, buddy, that's fine. Anybody else have any idea why that might be a bad idea? Ariel?
You can miss some clues.
Miss some clues, kind of like, what's the clue? Like the directions? Because in math, there's all different kinds of ways to solve a problem, or things a problem might ask you to do. Think about some of the directions you've had already today. What have we asked you guys to do earlier? A couple problems earlier. Started with an E. Anybody remember? We asked you to do a problem by doing what? Not exponents, but evaluate, right? Who can remind me, what's that mean, evaluate? What are you doing when you evaluate? Somebody help me out. When you evaluate a problem. Shannon?
You're solving the problem?
Yeah, solve the problem, but remember, we're giving you, the book, or Mr. Hager and I, we're giving you values. We're saying x equals 2, y equals 1. Then wherever you see those letters in the problem, you're going to plug in those numbers. That's evaluate. Look at the board. Someone tell me by raising their hand. What's the directions in these two problems, I and J? What do the directions say? Simplify. Anyone know what that means? Anyone know what simplify means? I want to give their own definition.
Break down the problem into the answer.
Into the answer. Is it Emily?
Yeah.
Emily, is it always going to be a nice, like, one number answer, like 25, 205, 7? No. What might it have?
There could be, like a decimal
Could be a decimal. What else?
or a fraction.
Could be a fraction. What else? What else do we see in that? What's your name? Al? Yeah?
It could be an equation.
Could be an equation. Okay, kind of. What else? Shannon?
It could have variables.
Could have variables. Good. That's one thing I was thinking. Anybody else? Might have signs too. Might have a plus sign, might have a minus sign. Simplify means, guys, go as far as you can. So you could have like a variable, you could have 4x plus 2 equals 27. 3a minus 5 plus 2y. You could have all those different things. So simplify, again, understand, you might not get a nice one number answer. You might have some letters, you might have some variables, you might have some signs, you might have numbers too. So that's what simplify means. So keep that in mind. Read those directions, because sometimes I'm not really good at math. I've gotten better at it the last couple of years, but in math, I don't want to do more than I need to do. Maybe it's just asking me to identify something. Identify the variable in this problem. Identify, identify the two operations this problem is asking you to do. So make sure you read those directions, because a lot of times in past years, Mr. Hager and I have had kids that have done more than they needed to. So pay attention to those directions, all right?
Okay, so based on what Mr. Roy just said, does anybody think you're going to end up with letters in either of these problems? No. Chances are, if you didn't have letters to start, you're probably not going to have letters when you finish. So maybe something like when we get to L, you have something with letters, so if you were simplifying that, that might have letters in the final answer. Okay? But these two won't. Do you want to give those a couple minutes, Mr. White, and have them try that?
Sure.
All right, so why don't you guys take a couple minutes and
Yeah,
try to
probably
get those
done,
answers. Okay.
Because I know some of you guys were working while I was talking up there.
Yeah, you guys already done
Anybody
it?
need, like, anybody need more time to finish these two? Is everybody done? Everybody's done I and J? Need a little more time? All right, everybody's good? All right, so what do people get for I? Aiden, what you get?
I got 50.
50. All right, what's your name? I'm sorry. Marissa. I'm gonna get these names, just give me some time. Marissa, what you get? 50. How many 50s do we have out there? Any brave souls out there? Get anything different than 50? We all got 50? Hopefully I did it right. Perfect. So in this problem, for I, what's the first thing I should do? Yeah. What are we using for this? Order of operations, right? What's it? I'm sorry. What's your name again? Haley. You're absolutely right. But I'm just trying to making you think of the process. That's all. You said multiplication. That's perfect, right? Because we do PEMDAS. The M comes first. Yeah. Because what two are we got multiplication? Okay. What else do we have for an operation in this problem? We have multiplication and what else? Addition, right? So multiplication comes before division, right? I mean before addition or operations. Perfect. So we're going to get 5 times 4, 20. Bring my plus sign down to my 30. 30 plus 20, 50. Perfect. Right? So again, that's just a simple order of operations problem. All right, next one. What do people get? Marissa? 45. Emily? 45. Any other brave soul? What's your name? Vanessa. What you get? 45. Any brave souls? Get anything different? Faye? 30. Faye is brave enough to say you got 30. Well, hopefully, let's see what I got. So we had 45 and 30. Kyle? 30. Let's see. I got 45. So 3 to the second power. So I'm going to do, because that little 2 is called a what? Exponent, right? Perfect. So 3, so I'm going to get 6. No? So the people that got 30, is that what you did? Remember, and guys, believe me, in the history of math, in the history that Mr. Hager and I have done this class together, we've seen this hundreds of times. It doesn't mean 3 times 2. What does it mean? 3 times 3. It's this big number multiplied by that little number. That many times. You're going to multiply this big number together 2 times. If there was a 3 there, multiply the big number together 3 times. All right? That's all that means. It's not 3 times 2. And it's usually what we see is a lot of times is when people make mistakes, they make them with the smaller exponents because those numbers are easy to multiply. So I should get what? Not 6, but 9. Okay. So bring my 5 down. Why did I do exponents first? PEMDAS, right? And the P stands for parentheses. We didn't have any parentheses. We go to our E. E is what?
Exponent.
I got exponents, right? So 5 times 9? 45. That's where I got the 45 from. So again, guys, with those exponents, be careful. Right? It doesn't mean you're multiplying those 2 numbers together. Multiply the big number together as many times as the little number says. Right? Doesn't happen very often, but the little guy's in charge. Kind of like my wife. My wife's little, most of the time she's in charge. Kind of like Mr. Hager. And same thing in here. Even though I'm big and tall, Mr. Hager's in charge. All right. We got K. Now, be careful. Don't worry so much about L right now. How can I get 1 page, Mr. Hager? He's still, after all these years, he's still a technology guy. All right, so same thing we've been doing, all right? Order of operations, same exact thing. Don't get stumped by those brackets. Don't let those brackets scare you. They're not gonna hurt you, they're not gonna bite you. All right, good, this one. No, good. All right, guys, what did people get? This one's a little more involved than the ones we've done. Liam,
10.
you got 10. Aiden,
10.
10. Nini,
10.
10. Yes. Vanessa,
10.
I'm skipping you. Easily. Okay, any other people out there besides that didn't get 10? Ariel,
I got an 8.
you got what?
8.
8. All right, hopefully I did it right. 10. All right, so in this problem, Derek, what am I going to do first? What do you want to do first?
Parentheses.
Okay, what's in the parentheses?
18 minus 9.
18 minus 9. So I'm going to bring you okay with bringing everything else down? I'm going to bring the 16 plus, I'm going to start my bracket, I'm going to bring the 13 down, I'm going to bring the minus down. When you did 18 minus 9, what'd you get? 9. Cool. Do you want me to put those two sets of parentheses around the 9? No. Okay. But can I put a bracket on the end?
Yeah.
Okay, cool. All right, so what's the next thing? Nini, what's the next thing I'm gonna do? She's like, oh, Mr. White, I should have never told you Nini because I got a call on me.
13 minus 9.
What do you get?
4.
4. Okay. So we got 4 here. Boop, boop, boop. Actually, we can get rid of those. We don't need them anymore. We just solved them. 4. We're gonna bring this plus sign down. We're gonna bring the 6 down. Last but not least,
Don't say it. Don't say it.
what is it again?
Hannah.
Hannah. Okay, Hannah, what you got? 10. Did you have 10 at the beginning? Okay, good. Hannah says 10. Hannah is correct. Ariel?
How did you get the 9?
How'd I get the 9? I did, so I got the, I'm gonna treat these little brackets almost like they're parentheses. But I have another set of parentheses inside, so I'm gonna do that set of parentheses first. 18 minus 9 is 9.
Oh my gosh.
What'd you put? What'd you put?
I thought you
You don't wanna talk about it, okay. All right, so we got 10. Everyone good? Ariel, you good now? Okay with it? Okay. Next one. Now this one, you may not know yet, because there's a word up there. It says, in the example below, identify the like terms. Give the coefficient of each variable term. Oh, coefficient. Anybody know what it means? I know your last name is Yang, but I can't remember your first name. Josh. Can I call you Josh? Okay. Josh, what do you got, buddy?
It's the number before the variable.
Yeah, the number before the variable or the number attached to the variable. All right? If there's no variable, it's just a plain old number, then we don't have to worry about it. Only the coefficients are only going to be the numbers that are attached to the variable. All right? So take a second, and all we want you guys to do is identify the like terms and identify the coefficients. That's it. So identify like terms, identify the coefficients. So it's a two-part answer. So, Ashley, what did you get for your like terms?
Oh, I finished.
Didn't finish?
No.
Anybody finish? Marissa, what'd you get for your like terms?
3x.
3x and 5x. So that's one part. All right? 3x and 5x. Now, coefficients. Emma, what'd you get for your coefficients? Remember, the number attached or the number before the variables. So what numbers are attached to the x's? 3 and 5. That's it. That's all we needed for this one. So 3x and 5x were your like terms, and the coefficients were 3 and 5. How come 7 is not a like term? What, how come it's not like the others? Doesn't have an X, perfect. And these guys aren't like this because they're not just numbers, they're variables. Marissa?
The answer is an algebraic expression that's 7x plus
Say that again.
7. 7x plus 7 is an algebraic expression.
7x plus 7. No? Oh, you're simplifying. I like the plus 7, I like that a lot. But I'm going to disagree with your first part. 8x. We good? You agree with me or no? It's okay to disagree with me. Is 3 plus 5 8? Is 3 plus 5 8? Sure? All right, so 3 plus 5 is 3x and 5x is 8x plus 7. We didn't have to solve it, but Marissa wanted to, so we did. All right, next one. Solve using the distributive property. Does everybody know what math operation? I'm not going to tell you. I just hope everybody knows what math operation you have to use when you're doing the distributive property. Hope everybody knows. Ashley, can I call on you again?
Yeah.
Did you finish this one? Okay, cool. All right, so what'd you get? Nah, I want to know what you got first. 14. Anybody get something different than 14? Marissa? 45. Josh? Anybody else? Anybody else get something different? You said 14, right, Ashley? Sure. She's like, I don't remember. So 14, we got a 45 out there. Anything else besides 14 or 45?
I got 55.
55. Anybody else? Anybody else? Let's see what we got. 45. When we do the distributive property, what math operation do we have to use? Josh? Multiplication, right? Can you explain to me how it works, Josh?
You have to distribute the 5. You multiply 5 by 7 by 5 and 2 by 5.
Yeah, so you're basically taking the number on the outside and multiplying it by, and however, you could have 5 terms in here if you wanted to. Taking the number on the outside, multiplying it by however many numbers are inside. So 7 times 5, Josh?
35.
35. All right. 5 and 2?
10.
10. That's where I got my 45 from. Some of you guys might have been thinking order of operations. I mean, even if you did 7, added the 7 and the 2, you got 9, and then 9 times 5 is 45. Sometimes it might work out for you, but that's how we talked about earlier. It's important you read those directions. It said use the distributive property, use the distributive property. All right. I didn't write the directions for my health. All right. We got one more, Mr. Hager? 2 more. Okay.
This is a quick one, next one's a little.
Yeah, quick one. It should take like 10 seconds.
Now, before Mr. Roy does this one, how come you can even simplify that? How come you're going to be able to combine the first term with the second? What allows you to do that? Yeah, Josh?
They're like terms.
Exactly, they're like terms. They each have the same letter. Perfect.
So when we do that, what do we get?
I got 3Y.
You get 3y. Anybody else out there get anything besides 3y? No one. So everybody's good with 3y. So am I. 7 minus 4 is 3. They're like terms. We can combine them. Now, what if this was, say if this y was an x? If it was 7y minus 4x? What would our answer be?
Yep.
That's your answer. Right, Brett? Perfect. That's my answer. I can't do any more. How come I can't do any more? Brett? Yeah, that's different. I got an x and a y. Right? Good. Last one, Mr. Hager?
Last one.
Last one. So we got a combination of a few things going on here.
All right, so this one's a little more complicated. You think you're gonna end up with just a number in the final answer, just a letter, or both? Both. Anybody get an answer? Let's see what we got. Yep, Vanessa, right? Yes.
9 plus 25x.
9 plus 25x. Okay, any other answers? What else do we get? Yeah, Babe.
12x plus
12x plus 9. Okay, anything else? Yeah, Isolis?
21 times 5.
21 times 5x. All right, Brett.
21 plus 5.
21 plus 5x. All right, let's take a look at, I think I heard that, 25x plus 9. Anybody get that? All right, let's take a look. What's the first thing you have to do here? And we did this, I think, in the last problem. Yeah, Liam?
The parentheses.
All right, can you do anything inside the parentheses? Yeah, we don't have any like terms, but that's always where you want to start, inside the parentheses. How about anything outside then? Yeah? Yeah, do the distributive property with that 4. Everything else, just like Mr. Roy showed you, I'm going to copy it down because I'm not going to use it right now. What's 4 times 6x? 24x. And what's 4 times negative 2? Negative 8. And now, look what I've got here. I got 17 and a negative 8. Can I combine those? Yes, I can. Those are like terms. What's 17 minus 8? There's my 9. And I got 24x plus, what number is always in front of x if you don't see it? Yeah, it's a 1. What's 24x plus 1 more? 25x. Is that the same thing? Yeah, you can put 25x plus 9 or 9 plus 25x. All right, so right now Mr. Roy is passing out your homework. Okay, if you get the notes from today, the homework's going to be super easy. First homework of the year. This video will be online if you guys need to look anything up.
Guys, if you want that sheet that you wrote stuff down on today, your blank sheet of paper, you can use that on your homework.